This is the 9th question of UKMT Senior Mathematics Challenge exam for year 2025. The question says 50 squares are drawn side by side in a line. The first and last squares are shaded. Other squares in the line segment must be shaded such that both these rules apply. The first rule is no two adjacent squares are shaded, and the second rule is there are no more than 3 consecutive unshaded squares. Okay. What is the difference between the smallest and the largest number of squares that can be shaded? So first we'll see largest number of squares that can be shaded. So for me, what I'm going to do is, let's say this is so on, and this is the squares. This is the first square, second, third, fourth, fifth, so on till this is 50th square, this is 49, this is 48. Okay, to shade the largest number of squares, I know that first is shaded. It says first and last squares are shaded, and I know last is shaded. Now, what I need to do is, I have to apply both the rules. First is no two adjacent squares are shaded. That means adjacent squares are not shaded. That means I need a gap in between at least. But there should be no gap of more than 3 unshaded. So at max I can have 3 unshaded and then I'll shade one. So to get the largest number of shaded, what I'll do is I'll go on and shade all the alternate ones. So 5th is shaded, then 7th will be shaded. So 6th is not shaded, then 7th will be shaded, and so on. Okay, till 47th over here will be shaded. So 47th will be shaded. You look at it, odd numbers are shaded. After that, I cannot shade 49 because then 49 and 50 both will be shaded. It has said that last is shaded. Okay, but 2 cannot be shaded together. So this is the situation in which maximum number are shaded. So how many of them are here? Till 47, from 1 till 47 if I do, 24 are shaded, plus this 150th is shaded. So 25 is shaded. So the largest number I get is 25. Largest number is 25. Now I have to get the smallest number. Okay. So for smallest number, the first is shaded. And this is the 50th, let's say. So first is shaded. What I will do is, it says that 3 of them, you can leave 3 of them. There are no more than 3 consecutive unshaded. So I can leave the 2nd, 3rd, 4th, and then I'll shade the 5th. Then I'll leave the 6th, 7th, and 8th, and then I'll shade the 9th. So first is shaded, 5th is shaded, 9th is shaded. First is shaded, 5th is shaded, 9th is shaded. Okay, and then 13th will be shaded, then 17th will be shaded, so on. If you look at it, this is a multiple of 4 plus 1. So till 41 I get, and then 45. After 45, can I shade 49? No, I can't shade 49 because then 49 and 50 will be shaded. So this is 50 here. Because then 49 and 50 will be shaded. But can I leave all of them? Can I leave 49 also? No, I cannot leave 49 also. Because if I leave 49, I will have 4 unshaded. 46, 47, 48, 49. 4 will be unshaded. So after that 45, I have to shade 47 and then there will be 50 just shaded. Okay, or I have to shade after 45, I have to shade 48 and then 50. Okay, this is what I have to do. This is the least number. So I have to shade between 45 and 50, I have to shade at least one of them. So from here onwards, I will get one of them to be shaded. Now, how many are there from 1 till 45? So applying arithmetic progression rule, this is 45 equal to 1 plus n minus 1 into the differences of 4, common differences of 4. So if you count, 44 by 4 is 11, 11 is n minus 1, so n comes out to be 12. So it is 12 here, and 2 of them are here. So 12 plus 2. So 14 is the smallest number that has to be shaded. So from here, the smallest number is 14. What is the difference between then 25 and 14? 11 is the difference. Answer option C, 11 is the right answer.